Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on November 18, 2025, about 5 days ago. It introduces Dental3R, a pose-free, graph-guided pipeline that reconstructs detailed three-dimensional teeth and bite geometry from just 3 unposed smartphone photos, reaching PSNR 33.89, SSIM 0.949, and LPIPS 0.137, and clearly beating strong, three-dimensional Gaussian splatting baselines on novel view quality. The paper is titled Dental3R, Geometry-Aware Pairing for Intraoral 3D Reconstruction from Sparse-View Photographs. And, as we will see later, the implications for remote orthodontic care are quite significant. Alright, the introduction just highlighted why sparse, unposed photos are so challenging, and Figure 1 now lays out how the full Dental3R pipeline tackles that. The left panel shows the input stream, a handful of uncalibrated intraoral photos taken from different angles. The middle panel illustrates the geometry-aware pairing strategy, which selects overlapping image pairs and organizes them into subgraphs for stable pose and depth recovery. The right panel depicts the three-dimensional Gaussian splatting optimization, where rendered views are matched to ground truth both in raw color and in wavelet space, so that the final three-dimensional teeth model stays sharp without noisy artifacts. Figure 2 compares rendered novel views from competing methods against ground truth, so it makes the visual impact of Dental3R very clear. The top 2 rows, CF3 DGS and Instant Splat, show blurrier enamel and smeared gum textures in the highlighted patches. The hours row produces crisper tooth boundaries and more coherent gingiva, which closely resemble the GT row. The zoomed-in boxes especially reveal sharper intertooth gaps and far fewer glittery artifacts on the enamel surface. The previous figure showed visual quality differences, and Table 1 now backs that up with numbers across different counts of training views. The table reports PSNR, SSIM, and LPIPS for 3, 6, 9, and 12 training views. Ours consistently matches or slightly beats Instant Splat on PSNR and SSIM, while achieving the lowest LPIPS. The gains are especially clear at 9 and 12 views, where ours delivers both sharper and more perceptually faithful reconstructions. Table I quantified the gains from Dental3R, and Figure 3 now shows how different image pairing strategies affect visual quality. The columns step from 3 to 12 training views, while the rows compare cosine pairing, complete pairing, one reference pairing, and the gaps pairing used in our method. Cosine and one reference produce noisy or smeared textures, especially with only 3 views. Complete pairing looks better, but still softens fine enamel details. Gaps delivers the cleanest, most consistent teeth and gum appearance across all view counts, so it confirms that geometry-aware pairing really stabilizes reconstruction. Well, Table 2 digs into why the geometry-aware pairing strategy matters for efficiency as well as quality. The table compares cosine, complete, one reference, our method without the wavelet loss, and our full method across 3, 6, 9, and 12 training views. Complete pairing sometimes edges out on PSNR or SSIM, but it explodes the number of pairs and GPU memory. Our method reaches similar or better image quality, with far fewer pairs and dramatically lower memory, especially at higher view counts. Alright, Table, I just examined the trade-off between quality and memory, and Table, I now zeroes in on the extreme 3 view setting against other published methods. The table reports PSNR, SSIM, LPIPS, and total training time in seconds. Instant Splat reaches PSNR about 33 and SSIM about 0.95, but our method pushes PSNR to about 34 with the same SSIM and noticeably lower LPIPS. Our method also stays reasonably fast at about 64 seconds, just slightly slower than Instant Splat and vastly quicker than CF3 DGS. So stepping back, the big takeaway is that Dental3R shows pose-free. Sparse photo inputs can still yield accurate three-dimensional bite reconstructions, thanks to geometry-aware pairing and a wavelet-guided loss that preserves fine dental details. This unlocks more reliable remote orthodontic assessments from simple smartphone photos. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.